In the last video, we looked at writing basic functions that took a couple inputs potentially and just simply returned a calculation on those inputs as the output. But we can do some more complicated things with functions, and so in this video, we're going to look at what are called conditionals. And conditionals are simply a way in which we make decisions in programming. Classically, they are called if-then statements. And so we evaluate a condition to see whether or not it's true or false, and if that condition is true, then we execute one set of code, and if that condition is false, then we do something different. So let's look at a quick example. We're going to define a new function, and I encourage you to be doing this along with me because you get a better feel for the syntax, and it's easier to remember how to do these things on your own if you've typed these things yourself rather than just sort of watching the video. So I'm going to create a new function. I'm going to call it find maximum. Okay, so remember def to define a new function, find underscore maximum. Okay, and it's going to take two inputs, and I'm going to call them A and B. Remember, we finished a definition of a function, that line with a colon to indicate that what's following is a block of code defining the function. And now what I'm going to do is decide which of the two, A or B, is the larger value. And the way I do that is with what's called a conditional. And so a conditional, again, is an if statement. So what we say is if, okay, and I want to know, is A greater than B? Well, following the if is the condition, and so the condition that I want to check is A greater than B? Now, again, I'm going to hit a colon because I want to define a block of code that is the consequence of A being greater than B. So if A is indeed greater than B, if this, in other words, evaluates to true, remember we did that in the shell, we tried in a couple videos ago, we said 3 greater than 4 and it returned a false value, or 3 less than 4 and it returned a true value. So that's what's happening here. This, what I've highlighted, A greater than B, is going to be either true or false. If it is true, then that next indented block is what is going to happen. So if it is true that A is greater than B, then A is the maximum of the two. And so I want to return the A value. Okay? Otherwise, either B is greater than A or they're the same. And in either case, I'm just going to return the B value because B is the maximum, or they're both the same, and so they're both the maximum. So how do I handle that? Well, if A is greater than B, return A. Otherwise, return B. The otherwise portion we write by writing an else statement. Okay, and else is again a keyword in Python. You can see that it's orange there as we type it. So else colon, meaning the next indented block, is what happens if A is not greater than B, if this condition evaluates to false. So if the condition evaluates to true, do this indented block. Otherwise, the condition evaluates to false, we're going to do this indented block. And what we want to do is return B. Okay. Notice when I hit enter, Python assumes I'm still indented. I can back out with backspaces to get back to different levels of indentation. The indenting is important. Indenting is how Python tells where a block of code begins and ends. And so if this return A, for instance, were not indented, I would actually get an error when I try to run this. Let's actually do that just to show you. I'll save that again. It says expected an indented block. It saw a colon and expected the next block to be indented. So don't ignore the indentations. Those are key. They're not just for readability or aesthetics. Unlike in most languages, Python actually uses the indenting as a syntactical construct. So let's run this again now that I have this defined correctly. We'll save it. Okay, it's defined my functions. And now I can ask the question, what is the maximum? Find maximum. I'm going to make a function call, right? Find maximum of, and you can even see as soon as I type the word find maximum in the parenthesis, because it now recognizes that symbol as having been defined, it tells me right there it's expecting two inputs, A and B. So let's say I want to find the maximum between 10 and 3, and it gives me 10 because it's returning that, right? Let's say I want to find, I'll reverse them, maximum of, we'll put the smaller one first, 2 and 8. It returns 8, the B, okay? So that function's working well. And this is how we make decisions in Python with if statements. Let's look at one a little more complicated, right? This is a kind of a binary decision. Either A is greater than B or it's not. But a lot of times, decisions are more complicated than that. So let's define a function that gives a student's letter grade based on their percentage. So we'll define that function and call it letter grade. And the input will be percentage. Notice these names are names I'm choosing to be meaningful. I don't have a choice about the keyword def. That's part of the language. But letter grade is my choice, and percentage is my choice. You want to choose names of functions and variables that have meaning and that make sense for the context of your program, so that people can read that program and understand what's going on, even if maybe they don't even know how to code. Okay, so I want to know what's the letter grade for a given percentage. Well, if the percentage is greater than 90, let's say greater than or equal to 90, then that letter grade should be an A. So I'm going to return the character, the string, A. But what if it's not? I don't want to say else here because else means in every other case, right? Up in find maximum, if A were greater than B, then I want to return A, but in every other case, I wanted to return B. Well, now I have more than one choice. I don't have a binary choice. I might want B or C or D or F, right? So I can't just say else here. I have to evaluate if percentage is greater than 80, okay? And so I want to say else if, right? And so the way we do that in Python is they kind of shorten that into a contraction called elif, and that means else if. So if the percentage is greater than or equal to 90, return an A. Otherwise, if the percentage, so we need a second condition here. If the percentage is greater than or equal to 80, return B. Now at this point, we want to stop and explain something here. First thing is, as soon as a function hits a return statement, that function is done. Return means we are giving this output and nothing else will happen in this function. So if the percentage we're saying 92, we'd come down here, is 92 greater than or equal to 90? Yes, return A, nothing else beneath this return statement ever executes. Okay, so I don't have to worry about the fact that 92 is also greater than or equal to 80. It won't also return B. It's as soon as it hits a return value, done. Okay, return statement means you're done. So you want to make sure that you're not returning before you intend to, right? As soon as you hit a return, nothing else happens. Secondly, we can only return one value, so we want to make sure that when we are executing functions, that the value we are creating, is the thing we want to return, right? That we're only returning once we're done processing the input. Okay, so now I come down here, elif percentage is greater than or equal to 80. So I don't have to worry that 92 is greater than 80 because it won't ever get there. If it's not greater than 90, so if it's like an 87, then this runs, right? And we return that. But what if the percentage is not greater than or equal to 80? Well, I want to know if then, otherwise, if the percentage is greater than or equal to 70. Okay, and so you can notice here that I can have multiple elifs, and so we can have multiple conditions checked in the same sort of conditional statement here. Okay, and so on. Now the last condition is the F condition. I could say elif percentage is less than 60, but that's kind of redundant because if percentage is greater than or equal to 60, it would have satisfied one of these four conditions above. So the last condition we often use an else statement. Okay? In all other cases, return an f. And there's our function. So let's execute that function. Let's run the module, define that function. Okay, and now I can ask, what's the letter grade for an 83? And it'll tell me B. Okay, and I can even assign that value to a variable, right? I can say the grade is letter grade of 67. And then I can ask, well, what's the grade? It's a D. Okay, so we can use the return values of functions as the right-hand side of an assignment statement and assign those return values to a function. And it's basically a substitution that's happening here, right? We execute the function, and this whole letter grade of 67 becomes, if you will, a D, and that's what grade gets assigned to. Let's do one more function, and we will talk about compound conditionals. So sometimes we want to make more complicated decisions than simply comparing one value to another. Let's make a function called isNiceOut. Okay. Now, when you start a function with the word is, typically you're returning true or false. It either is, it's true, or it's false, right? That's why that's how we denote that, isNiceOut. So it's either true that it's nice out or it's false that it's nice out. And the inputs to this are going to be the temperature and the humidity. Okay, and we're going to say it's nice out. Let's say if the temperature is between 60 and 80, let's say. Okay, now we can do that very nicely in Python in one statement. So if 60 is less than temperature, and that's less than 80, and it's only nice out if the humidity is less than 70. If it's too humid, it's not nice out. So I don't want to just look at the temperature. I also want to look at the humidity. And so when we do that, that's called a compound condition. And so I want an and here. So I want two things to be true. And the humidity is less than 70. So now both of these conditions have to be true in order for this whole condition to evaluate to true. And so we will return true here. Now again, remember, true, you can see that it's an orange in orange here. It's a Python keyword. That's a legitimate value. That's called a Boolean value. So we can return that as a value, just like we would return a number or a string, right? Otherwise, we want to return false. Okay. Let's run that. And I can ask, is nice out, 50 degrees and 50% humidity? Nope, false. It's not nice out. Is it nice out at 65 degrees and 40% humidity? Yes, true, it is nice out. Okay, so these functions are making decisions based on the inputs and giving back that information as the output. Okay, we're going to wrap up this discussion of functions with some built-in functions that already exist in Python that so we can kind of see, you've actually used some already, but we're going to look at some common ones so that you're comfortable with them. Let's go back to the notion of lists. I'm going to create a new list called nums, and it's going to be 3, 1, 4, 1, 5, 9, 2, 6. Okay. Random set of numbers there. And I want to know how long that list is. Well, you and I can look at it and count. However, oftentimes in a program, we'll want to know, lists can change their length, and we might want to know at any given time within a program how long a list is. And so we can use the built-in function len, which is short for length. Notice it's purple. In Python, those built-in functions will turn purple to let you know that that's an already defined symbol built into Python. Now, again, it's a function, right? And we know that when we use functions, we call them with parentheses and the parameters inside. So if this is a function, then I call it with a parenthesis, and it will tell me we're expecting an object as a parameter. And the object that we're going to send in is nums. Okay, the input to this length function is nums, and the output is how many items are in there, right? So if we type that, it says 8. 1, 2, 3, 4, 5, 6, 7, 8. Yes. Okay, so the length of that list is 8. That's how many items are in the list. Another built-in function that you might want to know about is sum, right? We can sum a list as well. So sum does what you would expect, adds up the items in the list, 31, and you can check to see that that's correct. Um, there's a built-in function called min, which will find the smallest item in the list. Now in this case, the minimum's 1. It happens twice, but it's still the minimum, and so that's what you get. Likewise, you could expect there's a max function, which will return 9 in this case, because 9 is the largest item in the list. To wrap up our discussion of the built-in functions, let's go back to the dictionary we created a couple videos ago about the months. So we had this months dictionary, and we had the keys as the names of the months and the values as the number of days in the months. Let's add December in there. And we were able to access values based on the keys, etc. I want to just point out that we can use some of the built-in functions on dictionaries as well. So if I want the length of months, well, that's going to give me back the number of key value pairs, which is 12. I can also nest functions, right? So what I mean by that is maybe I want the sum of all of the values in the months. So this was another function that we'd used. Notice values has open and close parentheses here. That's a parameter list. It's an empty parameter list, but it's a parameter list nonetheless. It means that values is a function that belongs to the months dictionary. And so the return value of this values function is the list of the number of days in each month. And so the sum function, as we know from earlier here, sums up all the items in a list. This sum function will sum up all of the values that are returned by the values function applied to the month's dictionary. So if we do that, we get 365, as we'd expect. So just to kind of reiterate the usage of those built-in functions and help you to see that this is like a composition of functions, like in math class, like an f of g of x kind of situation. You can do the same kinds of things in programming, Python specifically, and this will be something that we use in the projects that we do. So that's it. See you in the next video.